We have created our parts and now it's time to put them into an assembly. So we'll go New, find our default assembly. We are in millimeters, grams, and seconds. It's set to start begin assembly, insert component when we launch the assembly. So we're going to identify the base piece or the first piece that everything connects to. So if I open this, we can position it. Now on this version, we have show rotate context toolbar will be this one. And this is going to make it a little easier because I can rotate it, and then when I accept the OK, it's in position origin to origin. If that hadn't been the case, then I would need to float it. And let's go ahead and do that. If yours is in position, you can leave it. If I float, now this is able to move. And we're kind of at that point of, am I moving, rotating the component or the view? So be aware that there's times where you may be moving the component and think you're in the view. All right, so if it did not come in the correct position, we're going to float it. I'm going to expand out, and then this is one of those cases that the front plane and the front plane, well, that didn't quite go. That's right, I rotated it already. So let's take and deselect the front plane, and we'll hold down the control and go to the right plane. Those become coincident. If you're not familiar with the icons yet, we can go to the paperclip. All right, so up to the command manager under the assembly, and we'll find the mate references. And here we'll have to do the flyout if we want to stay with the planes. Now we could just go face to plane, and face to plane, and that would be fine. If I want to stay on center, though, I'm going to go with the planes and the rotation. Okay, so the top, and then the last one we did the front of the part to the right of the assembly. All right, so just to kind of get a concept. So instead of the F, we now have nothing in there. It's fully defined and ready to go. All right, so when we did the ends, I made one with a configuration and one that was standard. So we want to either from the insert component existing part and assembly or insert components, pick so that we get back into, and the only difference between begin assembly and insert component is the begin assembly launches with the part or with the assembly file. So let's bring in the fixed jaw, and there are no configurations to display, just the default. So if I were to bring this in, let's go ahead and rotate it now. Oh, this one is doing it as well. So if the in context isn't shown, you can right click and it will allow you to rotate about Y, in this case, X or Z. So if I rotate about Y, now that actually puts it to the counter bore is facing in, not really what I wanted. We'll go ahead and place it, and then this is where we're going to get good at rotating. So let's stay in the mate references for a little while. And so picking a face and going to another face. And then we could go face to face and face to face. The only issue is that there's not really a lot of error checking if these hole locations move. In the assembly process, those holes staying in alignment are pretty important, even if they get off a little bit. Maybe I make a change to make something fit or to adjust from the 19.5 to 19 millimeters for whatever reason. If it doesn't carry over to the body, then I'm going to have a misalignment. When it goes to manufacture, it's not going to go together. But if I use the concentricity between the cylinders, all right, so concentric, and if I rotate around to where I can see both cylinders, and this is also a kind of a perceptual thing, then I just want to make sure that I get everything in alignment to go that route. All right, so that's the fixed jaw without the configuration. So let's go insert component. We'll go the fixed end. And it comes in and it looks exactly the same. And we'll go with the mate. Since I pre-selected one of them, it will show up in the list. And we can accept, and we'll do basically the same thing. All right, so I'm going to move that out of the way. Do not try to pick those little tiny geometries from way out. Make sure that you zoom in and have a good reference to work from. All right, and if we're looking for those cylinders, rotating around until you can see them and pick them easily, having those big targets is going to help. All right, so the fixed end, because it has the configuration for the M5, I can switch it to the M12 tapped hole. All right, so the M5s go away, the M12 is in there. If I had used this one, and we could replace it, I could delete it and insert another one. There is also a replace somewhere down in there. And the advantage of the configuration is going to be that we can switch easily or have multiple parts and do what if scenarios, see how these are going to operate. Next, let's bring in the floating jaw, and I kind of pop between the insert components. A lot of times for screen space, I will collapse the command manager and use the pull downs. So there's whichever one makes the most sense. All right, so the whole location is pointed the wrong direction here, so I'm going to look at my reference triad and we're going to rotate about Y. And one more time gets it into position. All right, for the control select, if I go, all right, there's the right plane. That doesn't really help. The top plane, the front plane of the part to the front plane of the assembly is going to center it. It's going to sit on that face and that face, so those become coincident. And then because this can move, I'm going to make it static first so it doesn't do anything strange while I'm completing. And then in our next video, we will take a look at making it a dynamic. So let's put a distance. If I go into the select and control select, we have a distance mate, and 40 millimeters should be plenty. All right, so this is going to be a continuous repetitive process of bring in a part, apply the mates, and then bring in the next part. If you bring in all of the parts, it's going to make everything a lot more difficult. Just to keep track of and go through the process. So this one we're going to rotate about Y. Again, I'm going to go select, control select, and go with a coincident mate. All right, we're going to do that again. I know that one was a little fast. So let's take a look at the difference. If I go coincident and select, control select, and go coincident, and then I can see that the holes are lined up, but if those holes change, there's not going to be any misalignment, any mate reference error to tell me that I've changed something or something was changed and there is an issue with it. So we can go insert component again, or I can hold down the control button and select the vice jaw and bring it in. Did not ask to rotate it in this case, so we're going to use the mate alignments. So select and control select, and we'll go coincident, and then we have a pop-up that says flip the mate alignment. And whatever it does, that's fine. If I want to see that that mate, we can expand out the component, expand out its mate, and edit the feature. All right, so there's the coincident, and then here are the mate alignments. There is also, just to be aware if I needed to do this quickly, there's a flip mate alignment on the right mouse button that I get it into position and it doesn't quite end up what I want, then I can change it one of those three ways. Alright, so concentric is going to be between the cylinder, hold down the button, the control button, and go to the other cylinder, and we'll make those concentric. And now this is able to rotate, so we'll get it a little closer into position. I still want to be able to see those cylinders. So as I'm rotating it up, I get it close, and then select, control select, concentric. All right, so as you go through and you get familiar with the process, we're pretty much going to go through those same steps. And the only, again, the only real difference is if I change, and why don't we go ahead and do that? I can, if I make a change from the assembly and it migrates to the part, so we know that the M5s are there. Maybe we're doing a design review and say this really needs to go to 38. When I rebuild it, it's going to let me know that there's now a misalignment. The distance between centers, the help, or the what's wrong, the help files, on occasion have more information, but most of the time we're just going to do a Control Z, or if it doesn't let me do the Control Z, I will just reverse the process and rebuild. And that corrects the misalignment. All right, so if I do that on this part, the fixed jaw, so as I highlight it, it shows me in the feature tree where it's located. And I go find the M5s, and let's change it to 38 and rebuild. There's no error. I am relying on the being able to rotate it and see that the misalignment is there. So doing the Control Z again didn't migrate back to the assembly. So no undo and rebuild. All right, so those are back. So we want to build in some logic that will help us with that error checking. We're going to insert a component. Let's go ahead and bring in the lead screw. And it again is kind of in the wrong direction. We do the rotate about Y, and then we're going to go concentric. All right, so the fastest is always going to be pick the face, and in the pop-up, select the mate. And then if we need to, we can go into the mate, and that face is still selected, so I'm going to clear the selections. And most of the time this is going to be in a push, so I'm going to go with those two faces. We have enough clearance for the keeper, so we're going to look at its alignment. One of the things with the cylinders is that I could make maybe the front plane parallel to the front plane, but we have in the concentric the ability to right click and lock the rotation, and that probably popped up when I completed the concentric mate, but I didn't pause to catch it. So that would be something we would look at. Let's stay with the insert component. Let's bring in the keeper. Put it in place. Alright, so if I forgot to rotate it, no big deal. We're going to rotate the assembly. I'm going to go with the arc and control select the cylinder and make those concentric. Rotates into position, and then we'll go concentric, and it's able to rotate about the axis. So we could have either locked the rotation, but in this case, because there's a little bit of separation there, I want to make those parallel. Now we can also start to see that there's an interference if this comes all the way back. So it may be better that it is located there and we end up with the gap and it contacting a little more on the radiuses. All right, so not a big deal, but we might want to make that pocket a little bit wider to make sure that we're not putting anything in bind. All right, insert component, existing part, grab the handle, and the handle can rotate about Y. And select, control select. It's going to be concentric. And there is the lock rotation. So the same as going over and identifying the mate in the assembly. And we'll lock the rotation. Alright, so I did not get into the caps, but we'll do the cap on the next video and open up the toolbox to bring in the fasteners. Oh, there was one mate, so the minus sign tells me we have the concentric. Alright, let's go with the right plane, and then because I would like to rotate this eventually, we're going to go to the right plane of the lead screw, and oh, that should have been the front plane. There we go. So it pops up with an error, tells me, yeah, I don't think you want that one. Right plane of the handle to the front plane of the lead screw. We'll go coincident, and that will center it. Okay, so next video we'll put the caps on, add the features, and make this the toolbox fasteners and make this dynamic.